Hello everyone, welcome to our lecture number 2. This is our class 10 science physics chapter, that is light, and in this lecture we will discuss regarding your reflection and its types. Yes, so let's start the topic. So first is our reflection of light. So out of different phenomena of light, that means you can think about reflection, refraction, dispersion, interference, polarization, photoelectric effect, etc. Out of all these things, reflection is one of the special phenomena in which medium remains same. Remember one thing. So what is reflection of light? We can say it is the property of light. It is the property of light due to which light is able to come back to the same medium. Light is able to come back to same medium after incidenting on a reflecting surface. After incidenting on a reflecting surface. So what is reflecting surface? We will discuss wait. After incidenting on a reflecting surface. So surface from which reflection takes place. Surface on which reflection takes place, that is called reflecting surface. Next is some common points related to reflection. So next common point is, we can say the surface which reflects light is known as reflector. It's called reflector. Yes. So next is what? Next is third point. So in third point we can say most commonly used reflector in our daily life, that is your looking glass or plane mirror. So remember, polished metal surfaces are good reflector. Polished metal surfaces are good reflectors. Yes, and remember one thing, silver metal surface is the best reflector of light. It is the best reflector of light, and most commonly used reflector in our daily life is plane mirror. Most commonly used reflector in our daily life is plane mirror or looking glass. Yes, okay. And I have told one more point, that is, out of all the phenomena related to light, in reflection only, path of light ray changes without any change in medium. So in last point we can say, or we can write, in reflection, path of light ray changes. Path of light ray changes without any change in medium. Without any change in medium. Yes. So listen the lecture properly and write all the points in your copy. After that, you can revise it properly. Yes. So next is, we will discuss regarding your types of reflection. Yes. So next come to types of reflection. So it is of two types, we know, types of reflection. One is your regular reflection, another one is irregular reflection, and basically you have to write the difference in between these two. So point wise I am trying to explain, listen it properly. So first is regular reflection. First draw the related diagram to this concept. Regular reflection takes place in plane surface or polished surface. Yes, plane reflecting surface or polished reflecting surface. So let's the example is plane mirror, one of the most common and best example. Yes. So let us consider parallel incident rays are coming towards the plane mirror. These are the parallel incident rays which are coming towards the plane mirror, and these are the parallel reflected rays also. Yes. So denote the incident and reflected ray with the help of arrow mark. And at the point of incidence, we may draw the normal like this. So these are the normals at the point of incidence. This dotted line, red color dotted line represents the normals at the point of incidence. Yes. So first point is, what is the meaning of regular reflection? That means we can write point number 1. If parallel rays are reflected, if parallel rays are reflected in such a way that all the reflected rays are also parallel to each other. All the reflected rays are also parallel to each other. Then such a reflection is called regular reflection. It's called regular reflection. Simple thing. Next thing, point number 2. It occurs only if the rays are falling on a highly smooth polished surface like plane mirror. Yes, so it occurs if the rays are falling on a highly smooth polished surface. Highly smooth polished surface like plane mirror. Bas. Next, point number 3. One more thing. It is also called specular reflection. Its other name is specular reflection. So it is also called specular reflection. Same meaning. Specular reflection. Then in point number 4, what we can write? Now see, all the normals drawn at the point of incidence are also parallel to each other. So this point we can add. Yes. So for such surfaces, the normals at all the point of incidence are parallel. For such surfaces, that means highly polished smooth surfaces, the normals at the point of incidence are parallel. Yes. Next, last point, laws of reflection. In today's class we will discuss. Just remember, laws of reflection holds good for regular reflection also. Laws of reflection holds good. Holds good means laws of reflection is satisfied. In this case, laws of reflection holds good in this reflection, in this type of reflection. I hope regarding your regular reflection, all the doubts already cleared. So now, and including all these points, you have to draw the diagram also. Remember this thing. Yes. So in diagram, what you have to write, in right hand side you can write parallel reflected rays. These are parallel reflected rays. Another one is, these are parallel incident rays. Parallel incident rays. Yes. Okay. And this is your plane mirror, you know. Next, come to our irregular reflection. Yes. Next, come to next part, that is irregular reflection. For such reflection, surface is what? Non-shiny, non-smooth. Yes, rough surface. Next one is irregular reflection. So irregular surfaces in the such type of reflection takes place in irregular surface. So irregular surface का diagram अभी हम लोग ऐसे draw कर पाओगे. So you can draw like this. Yes. Example of irregular surface or diagram of irregular surface. Draw like this in your copy. After that, you have to think about a parallel number of parallel incident rays. Yes. So देखो अभी ये है तुम्हारा parallel incident rays. Parallel incident rays are coming towards your irregular surface or irregular reflecting surface. Then after reflection, what will happen? After reflection, here at this point, this is your reflected ray, incident ray. For second incident ray, this will be the reflected ray. And for third incident ray, here this will be the reflected ray. And for fourth, this may be the reflected ray. Draw like this. Yes, thus. So at all the point of incidence, now you can draw the normal. Now see, these red color lines represents the normal at the point of incidence. Normal at all the point of incidence. Yes. And here you can see normals at all the point of incidence are not parallel to each other. So in language part, what we have to write? Now see, draw the diagram with proper arrow marks. Incident rays along with reflected rays. Yes. Okay. So in left hand side, we can write these are incident rays, and in right hand side, these are reflected rays. In first point, what we have to write? You can write if parallel rays fall on an irregular surface. If parallel rays fall on an irregular surface, what will happen? Then reflected rays starts to scatter in all directions. Then reflected rays scatter in all directions. Yes. Such reflection is called irregular reflection. Such reflection is called irregular reflection. I hope the meaning of irregular reflection is clear. Next, come to second point. Yes. It occurs if the rays are falling on which type of surface? Rough surface. It occurs if the rays are falling on a rough surface. Rough surface, or you may say non-shiny surface. Sorry, non-shiny surface. Yes. Next, come to third point. In third point, what we can write? It is also called diffused reflection. Other name of regular reflection is specular reflection, but irregular reflection also called diffused reflection. It is also called diffused reflection. Next is point number 4. For such surface, normals at all the point of incidence are not parallel. For such surface, normals at all the point of incidence are not parallel. Yes. Next is our point number 5. So now think whether laws of reflection will satisfy in this case or not. The answer is here also laws of reflection is true. Yes. So laws of reflection holds good in this reflection, in this type also. Yes. Okay. So this is about your regular and irregular reflection. Now basically we will discuss terms connected with reflection of light. Yes. So give heading diagrammatic explanation of reflection with all terms connected to it. So lengthy heading, yes. Okay, don't worry about this heading. So diagrammatic explanation of reflection with all terms connected to it. First draw a general diagram. Yes, this is your what? This is your plane mirror reflecting surface. Yes, let us think about a normal. This is your normal. Yes, normal drawn at the point of incidence. Now see, this is your normal. Now this is your incident ray approaching towards reflecting surface, and this is your reflected ray. Yes, so first we will describe what is, okay, give naming x, y, then this is O, this is your N, this is I, and this is your R. Okay, so in diagram xy is what? Xy is reflecting surface. Xy is reflecting surface. So what you have to write? Surface on which reflection takes place. It means surface on which reflection takes place. That is your reflecting surface. Next is your O. O is called your point of incidence. O is your point of incidence, the point O. So what is point of incidence? What you have to write in its meaning? It is a point on reflecting surface at which incident ray strikes. Yes, so it is a point on रिफ्लेक्टिंग सरफेस के ऊपर ही एक पॉइंट है जिसके ऊपर इंसिडेंट रे फॉल हो रहा है. सो इट इज ए पॉइंट ऑन रिफ्लेक्टिंग सरफेस. इट इज ए पॉइंट ऑन रिफ्लेक्टिंग सरफेस at which incident ray falls. Yes, next is your IO. Diagram पे आरो मार देखो I2O. IO is your incident ray. IO is incident ray. So what is this? Ray approaching towards the reflecting surface. So ray approaching towards reflecting surface. Yes, that is your incident ray. Next is your OR. O to R. OR is reflected ray. OR is reflected ray. What is this? You can write ray which is coming back from the reflecting surface. Yes, ray which is moving away from reflecting surface. You can also write the ray which is coming back from the reflecting surface, that is from the point of incidence to the same medium. So ray which is moving away from the reflecting surface to the same medium. Yes, that is your reflected ray, O to R. Then one more thing is there, ON. ON in the diagram, it is normal. What is normal? Now in language we can write it is a vertical line drawn at the point of incidence. So vertical line drawn at the point of incidence. Yes, okay, drawn at the point of incidence which is perpendicular to reflecting surface. That is perpendicular to reflecting surface. Yes, that is called normal. Next, one of the most common thing is angle of incidence, angle I. In diagram it is I and this angle is angle R. So what is angle of incidence? It is the angle between incident ray and normal at the point of incidence. Similarly, angle of reflection, angle between reflected ray and normal is called angle of reflection, denoted by R. So in next page, now we can write angle of incidence. Give heading angle of incidence. Yes, Next is our angle of incidence, next term. Angle of incidence. Yes, so in figure that angle is your ION, angle ION, that is I, angle I. So it is the angle between incident ray and normal, incident ray and normal. Yes, next angle of reflection. Angle of reflection is the angle between, and in figure it is your angle RON, angle RON shortly represented by angle R. So it is angle between reflected ray and normal, reflected ray and normal. Yes, I hope it is clear. Reflected ray and normal. Next, one more thing, interesting thing is there in this diagram. Now see, there is an angle in between reflecting surface and incident ray. This angle is called glance angle of incidence, GI. And angle between reflecting surface and reflected ray, this is called GR. Is it clear? Glance angle of reflection. Same thing, right? Denote it as GI. This angle is GI and this angle is GR. Yes. Okay. So next is our what? Glance angle of incidence. Next term is glance angle of incidence, denoted by GI. So angle between, what you have to write? Angle between incident ray and reflecting surface. Incident ray and reflecting surface. Yes. Next is glance angle of reflection. Glance angle of reflection, that is GR. Again it is angle between reflected ray and reflecting surface. Reflected ray and reflecting surface. I hope all these things is clear to all of you. Yes, so listen all the lesson, all the concepts with full of patience. Yes, next come to laws of reflection. If you think that the speed is very less, then you can enhance the speed. Yes, so you can choose playback speed, choose that playback speed 1.5, otherwise 2.0. So laws of reflection, we know there are two laws. Yes, so it has been found experimentally that rays undergoing reflection follow two types of laws. One is your first law, another one is second law. So first law, it is very well known to you, that is your incident ray, reflected ray and normal at the point of incidence all lie in the same plane. Same plane doesn't mean that the mirror, that is not the meaning. Yes, मिरर के ऊपर रिफ्लेक्शन हो रहा है. यस, तो तीनों थिंग नॉर्मल, इंसिडेंट रे एंड रिफ्लेक्टेड रे, ये इस तीनों एक पॉइंट के साथ कनेक्ट है, वो है पॉइंट ऑफ इंसिडेंस, दैट इज ऑन द रिफ्लेक्टिंग सरफेस. बट इट डज नॉट मीन दैट द ऑल लाइन सेम प्लेन मीन दैट इज द मिरर. So first law, second law and first law and second law. First law is incident ray, next reflected ray and normal at the point of incidence. Normal at the point of incidence to the reflecting surface. To the reflecting surface, all lie in same plane. All lie in same plane. Yes, so in this figure now see, if this is your reflecting surface, all lie in same plane का मतलब क्या है? This is suppose your incident ray, this one is reflected ray and this is your normal. Yes, incident ray, reflected, normal, I and R all lie in same plane means here the plane is my screen of the tablet. Here the plane is screen of the tablet. So now see, all are lying on the same plane. Yes. Then come to your second law. It is very simple, very simple. The second law is angle of incidence is equals to angle of reflection. Angle of incidence is equal to angle of reflection. Yes. Okay. So one of the important note point is there. Always remember. From this note point, you may face assertion region question. Remember one thing. After reflection, velocity, after reflection, speed, wavelength, and frequency of light remains same, but intensity decreases. This explanation actually included in higher class. Intensity decreases means some part of the light, if the total amount of incident light is 100%, then out of 100% some part gets absorbed by the surface. Yes. So किसी भी surface के ऊपर light continuously fall होने के बाद वो surface क्या हो जाएगा, heat हो जाएगा. That means some portion of the energy gets absorbed by the surface, so that it becomes hot after some time. And maximum portion, if that is solid surface, then maximum portion out of the whole gets reflected back to the same medium. Yes. So because of this reason, intensity decreases. Yes. Because of this reason, intensity decreases. I hope this is clear. Then listen to one of the interesting concept, that is your reflectance. What is this reflectance? So remember, it is the ratio. Reflectance is ratio. Reflectance is equals to the ratio of amount of light reflected from a surface divided by amount of light falling on the surface divided by amount of light falling on the surface. Yes. And always remember, reflectance is a pure ratio, so it has no unit. It is expressed in percentage. Reflectance is expressed in percentage. Clear? Yes. So for more knowledge, you can remember these 2 points. Surface made up of silver, it has 95% reflectance. It means if 100 number of rays will fall on the reflecting surface that is made up of silver, then out of 100, 95 or more than 95 gets reflected back. Very less amount of light energy gets absorbed by the surface. Okay. Then another one thing, surface made up of coal, that is your 4% reflectance. It is having 4% reflectance. Yes. Let's discuss another topic, that is deviation produced by plane mirror. I hope reflectance is clear. Yes. And another one is your diagrammatic explanation of reflection with all terms connected to it. We have already finished. Yes. Okay, you can take the screenshot. Okay, done. Next one is this page. Then take the screenshot of reflectance. Yes. Next come to our topic, that is your deviation produced by plane mirror. Deviation produced by plane mirror. What is the meaning of deviation? Deviation means अपना ओरिजिनल रास्ते से भटक जाना. Okay? Yes. In this age, parents are telling to you that don't deviate from your path. Don't deviate from your path means it's the age to study. It's the age to acquire knowledge. So don't distract your mind. Yes, don't engage your mind upon different disgusting things. Okay, just like free fires. Yes, like this. Okay, so apart from this joke, come to the topic deviation produced by plane mirror. It means what? Suppose this is the diagram. Let's draw the diagram. After the diagram, you can understand easily. This is our reflecting surface, and this is your normal. This is the normal. Okay, make it dotted, and this one is your incident ray. This one is the incident ray. This one is reflected ray. Incident ray, another one is reflected ray. Yes. Here this angle is angle I. This angle is angle R. Very good. Next is, so what is the direction of incident ray? Array, light follows rectilinear propagation na. This is the property of light, to travel in a straight line path. Light always travel in straight line path. So this dotted line represents direction of incident ray. Direction of incident ray. This solid portion represents incident ray. Okay, but this dotted portion, this one, this represents direction of incident ray. And in RHS side, this is your reflected ray. This is your reflected ray. Yes. So now see what is the meaning of deviation. So light wants to travel in straight line path. Light wants to travel in this straight line path. But after reflection, it travel like this. So original रास्ते से वो कितना angle भटक गया? This is the angle denoted by delta. We can represent deviation in terms of delta symbol, Greek symbol, lowercase delta. Yes, capital letter, small letter. So remember, this is your capital delta or uppercase delta. This is your lowercase delta in Greek letter. Yes, okay. So no need to go in detail regarding your delta. Yes. Now see, this angle we can call it as angle of deviation, delta, lowercase delta. So this is your plane mirror. So in definition part, what we have to write? It is the angle between direction of incident ray and reflected ray. Very simple. It is the angle between direction of incident ray and reflected ray. So how can we find that angle? That's the issue. Now see, look at this picture. This is a straight line. Yes, and this total angle is 180 degree, obviously. So from figure, we can write angle I plus angle R plus angle delta is equals to 180 degree. So delta will be how much? 180 degree minus I minus R. Yes, so this can be written as angle I is equal to angle R. So delta is equal to 180 minus I, or delta is equals to 180 degree minus R minus R. So it will be delta is equals to 180 degree minus 2i, 180 degree minus 2i, or you can say delta is equals to 180 degree minus 2r. So this is the value of angle of deviation in case of plane mirror. Yes. Okay. I hope it is very, very simple for all of you. Yes. Now listen one more extra thing. Now see. The deviation produced by reflection at two mirrors. When two mirrors are inclined to each other at an angle theta. तो इसका डेरिवेशन मैं नहीं कर रहा हूँ अभी. ओके, इसको मैं डिराइव नहीं कर रहा हूँ, बस ऐसे ही लिख रहा हूँ. देखो, सपोज दिस इज वन मिरर, दिस इज मिरर वन and this one is mirror 2. This one is mirror 2. This is mirror M1 and this is mirror M2 and they are inclined with respect to each other at an angle theta. So in this case, the deviation produced by, for entrance only, you can remember the formula, otherwise it is not in your syllabus. Yes, it is completely not in your syllabus. It is an extra thing actually. The deviation produced by reflection at two mirrors inclined to each other at an angle theta is delta is equals to 360 degree minus 2 theta. Yes, in class 12 it will be discussed in a very very beautiful way. Yes, so wait up to that moment. Yes. Okay, another thing, in diagram I am trying to explain actually. Suppose two mirrors are perpendicular to each other. As shown in figure. Two mirrors are perpendicular to each other as shown in figure. Mirror 1 and mirror 2. Mirror 1, mirror 2. Suppose one incident ray is there. So condition is what? Two plane mirrors are inclined to each other at 90 degree. That means they are perpendicular to each other. Then reflected, the ray which is reflected, this is one thing. Then the ray which is reflected at two mirrors becomes parallel to incident ray. That means मैं बोलने ये वाला हूँ, देखो ये मैं बोलने वाला हूँ अभी, ये तुम्हारा incident ray suppose. So for first mirror this is the reflected ray. Yes. And the reflected ray of first mirror becomes the incident ray of second mirror. Now second mirror से reflection होने के बाद जो reflected ray हमको मिलेगा ना, वो reflected ray incident ray के साथ parallel होगा. Yes, the reflected ray of second mirror is parallel to incident ray of first mirror. Okay, that's I'm actually trying to explain. Clear? Yes. So reflected ray is parallel to incident ray. In this case, reflected ray of mirror 2 is parallel to incident ray of mirror 1. Incident ray of mirror 1. Yes, okay. Then this is the third note point. Very good. Next come to another case, that is your normal incidence. Acha, one more thing, laws of reflection. Remember, laws of reflection are obeyed by both plane as well as curved reflecting surface. Okay. In diagram, let's draw it. Next note point. What is that? Laws of reflection. Laws of reflection are obeyed by plane as well as curved reflecting surface. Plane as well as curved reflecting surface. So in diagram we can draw actually. So this is your plane reflecting surface. This is your curved reflecting surface. Let us think that this one is curved reflecting surface of which type? Of concave type. Curved reflecting surface of concave type, and this one is curved reflecting surface of convex type. ये तीनों केस में हम लोग लॉज ऑफ रिफ्लेक्शन सेटिस्फाई होगा. दिस इज द नॉर्मल. इन तीनों केस में देखो, दिस इज नॉर्मल, हियर दिस इज योर नॉर्मल, इन दिस केस दिस इज द नॉर्मल. मेक इट डॉटेड. अभी हम लोग क्या ड्रा करेंगे? Incident ray and reflected ray. Incident ray, this one is reflected ray. Here it is incident, this one is reflected, and this one is incident, another one is reflected. With proper direction, draw the diagram. So here angle I is equal to angular. Angle I is equals to angular. Yes, this one is angle I, angular. Incident ray, then reflected ray, normal at the point of incidence to the reflecting surface, all lie in same plane, and angle I is equal to angle R. That means laws of reflection are obeyed by both plane as well as curved reflecting surface. Yes. Next note point. Next is our normal incidence. What is normal incidence? Normal incidence. So when light ray falls perpendicular to the reflecting surface, then that is called normal incidence. When light ray falls perpendicular to reflecting surface, such type of incidence is called normal incidence. नहीं देखो, suppose this is your, let us think this is your normal. Let us think this dotted line represents normal. So मैं क्या बोलने वाला हूँ अभी मैं बोला if light ray falls perpendicular to reflecting surface like this, yes, this is your incident ray, this is your incident ray. So a ray of light incident normally on the mirror, in this case what will happen, this is the normal, also this line represents incident ray. So angle I in this case is how much? 0 degree. As per laws of reflection, angle R will be also 0 degree. That means reflected ray retraces the path. Re means again, trace means to change. Retraces again, that will follow the same path. Okay. So in language you have to write what? In language you can write a ray of light. A ray of light incident normally. A ray of light incident normally on the mirror. Normally on the mirror retraces its path. Retraces its path after reflection. Okay? Yes. Here angle I is equal to 0, angle R equal to 0. Don't think that angle I is 90 degree. Most of the students, maximum students are telling that angle I is equal to 90 degree in this case. No. Angle I is equal to angle R is equal to 0 degree. Yes. But what is the angle of deviation? What is the angle of deviation in this case? Angle of deviation formula, delta I is equals to 180 minus 2i. That means 180 degree minus 0. 2 into 0, that is 0. 180 डिग्री. कैसे हुआ 180 डिग्री? वो डायरेक्शन अभी टर्न हो रहा है, देखो ये दिस वन टू ट्रैवल इन स्ट्रेट लाइन पाथ. अभी 180 डिग्री टर्न करने के बाद ही वही सेम रास्ता वो फॉलो कर पाएगा. दैट मीन्स एंगल ऑफ डेविएशन इज 180 डिग्री, वी कैन से. ओके, आफ्टर नॉर्मल इंसिडेंट्स लेट्स डिस्कस लास्ट टॉपिक ऑफ टुडेज लेक्चर, दैट इज योर ग्रेजिंग इंसिडेंट्स. I know it is new to you. Grazing incidents, nahin? What is that? Now see, this is suppose your curved reflecting surface. This is your curved reflecting surface. Yes. And this is तुम्हारा light ray. At the point of incidence, can you draw the normal? This yellow color line represents the normal at the point of incidence, the reflecting surface. In this case, what will happen? ऐसे मूव करेगा वो. दिस वन इज इंसिडेंट रे. लेफ्ट साइड में क्या होगा? इन लेफ्ट साइड यू कैन राइट इंसिडेंट रे. राइट साइड दिस इज योर रिफ्लेक्टेड रे. इन राइट साइड यू कैन राइट रिफ्लेक्टेड रे एंड दिस वन इज नॉर्मल. यस. सो व्हाट इज ग्रेजिंग इंसिडेंट्स? इन दिस केस रिमेंबर, light strikes the reflecting surface tangentially. In this case, light strikes the reflecting surface tangentially. Yes, and in this case angle I is equal to angle R is equal to 90 degree. Angle between incident ray and normal, that is angle I 90 degree. Angle R also 90 degree. Yes, वो अभी डेविएट हो रहा है क्या? डेविएट नहीं हो रहा है. सो एंगल ऑफ डेविएशन कितना होगा? 180 माइनस 2i. 180 minus 2 into 90, that is 180 minus 180 0 डिग्री. सो अभी डेविएट नहीं हो रहा है. डेविएट नहीं हो रहा है मीन्स स्ट्रेट लाइन पाथ चला रहा है. ओके, स्ट्रेट लाइन पाथ चला रहा है अभी. दैट इज कॉल्ड जीरो डेविएशन. ओके, वो डेविएट नहीं हो रहा है अभी. आई होप दिस लेक्चर इज क्लियर टू ऑल ऑफ यू. यस, ज़्यादा हो गया, 45 मिनट्स का लेक्चर हो गया. ओके, थैंक यू, हैव ए नाइस डे. So kindly like, share and subscribe this channel for more updates. Yes.